So number 66. So this series of questions says convert the equation to rectangular coordinates. So say r squared. Do you have any conversion, anything related to sine 2 theta in our conversions? Anything related to sine 2 theta directly? Ah, cool. We can rewrite sine 2 theta in a better form, right? Because there's nothing in there about sine 2 theta. It doesn't say anywhere that r sine 2 theta equals something. But I do know what r sine theta is, and I know what r cosine theta is. And sine 2 theta is what?
2 sine theta.
And here's where people freak out for some reason. What does that side here need?
2 r's.
It needs 2 r's, right? This guy needs an r, and this guy needs an r. So what are you going to multiply both sides by? If you only multiply by r, he's going to get an r. He doesn't get shit. That's no good. Right? So you got to multiply by r squared. Completely. And it's all multiplication, so I can put the r squared back there if I wanted to. I can put 1 r there and 1 r over there. So what the hell am I going to do? I'm going to do the thing that makes most sense. I'm going to put 1 r in front of sine and 1 r in front of cosine. So what did I multiply this side by? R squared. I just, since it's all multiplication, I could put the factors anywhere I want to in that multiplication problem. So I'm going to put them where they make the most sense. So this freaks people out a little bit. I didn't distribute an r. Distribution would require what operation there? Addition, subtraction, along with multiplication, right? This is all multiplication. So I've got to give it 2 r's. And then we're golden.
2yx.
Yeah, this will be 2yx, sure.
And x squared plus y squared squared.
TKX. Cool. Alright, so anything else about that one? Let's see if I get an email from them before the answer key. Huh? Did I get them?
No.
No.
You got them.
You don't multiply that outright. You can leave that.
I just feel like being so evil right now to people that just... What's that?
You can't multiply that outright.
You don't want to.
Okay.
Why would you want
That's
to?
right.
Yeah. I mean, would it make any sense to try to solve for y or something in this case?
No.
Hopefully.
No, it's x squares, even in y squares. If I have that, I'm looking, now I got 4th powers. Bam. Yeah, it's done. Yeah. I like it. All right. You guys is wide open. Whatever the heck you want to talk about. Yeah.
7.5, number 26.
Oh, okay. So 7.5, number 26. So when you're solving equations, something that really shouldn't come to mind too often. Sometimes it might be helpful, most often it's not. Is on this problem, I wouldn't think about half-angle formula. And maybe a lot of you guys are like, no, I wouldn't. So you're safe there, right? Why would I not have to worry about thinking about like a half-angle formula here or something? Why do I not care about that? What's the last thing I do when I solve these equations?
Multiply by 2.
Yeah, on this particular problem, I'm going to multiply by 2 at the end. So I don't care that it's half an angle. Who cares? I'm going to solve for what theta over 2 is and then just multiply both sides by 2. So now the first step becomes, what the hell is the first step? And how are those things related? What's on both sides?
Theta over 2.
All right, that's what they have in common, but how are the trig functions related?
1 over
cosine.
Yeah, this is 1 over cosine, which goes with that. So it makes sense to kind of rewrite it like that. And then what can I do with this?
Multiply by cosine.
Yeah. So over here I get
Cosine squared.
cosine squared. Alright, and then of course what do I want to do? I have cosine squared equals 1.
Square. Square root.
There, okay, cool.
Sorry.
So the minute I take a square root,
Plus
Square
or
root,
minus.
plus or minus.
plus or minus, so get plus or minus 1 is
Cosine.
cosine.
Take a square over 2.
No, just 8 over 2, the square and the square root side. That square is squaring what?
Cosine.
Cosine. So when I write this, just remind you guys, it's the same thing as, it's the exact same idea as that. Those are the exact same idea.
There's flies.
Don't bugs, man.
I don't care. I don't like it near my ear.
Take a little hit before you come to class so you're even. Or whatever you gotta do. I don't want those imaginary bugs. I'm gonna start seeing them. They're there. They're there? Oh crap, we're all seeing them. Oh my god. What has happened to us? Which water fountain you guys drink out of? Stay away from that one. Alright, so is that cool? Just remember that. I haven't seen too many things where people were confusing those. But it's really easy to forget that that's what that says. When is cosine 1 or negative 1? So I'm solving for this guy.
0, 2 pi, and pi.
0. Is that true?
Yeah.
And
Pi.
pi. So 0.
Plus 2 pi.
Do 0 plus pi k.
Exactly.
Yeah,
Because
that's
it's 0 at 0.
Pi k.
It's 1 at 0. It's negative 1 at pi. So I can capture everything by going half rotation.
2 pi k.
No,
The
pi
end result's
k.
2 pi k.
No, it's not. It's plus pi.
Just 1 pi, right? To capture this guy, and then 1 pi to capture that guy.
And
I
then
got that, and then you multiply by 2.
There you go. Yours is way ahead of us.
0 plus 2 pi.
Bugs are whispering the answers to him. Yeah, multiply. Is that cool? Is that step all right? So on this, when you're solving this, you don't care what that is. You just see that as theta. So the angle is this, and then you solve this little thing for theta. Yes, ma'am.
Where did you get the 0 from? Like, other than it starting at 0, I don't understand where that's incorporated into it.
Say it one more time. Where did the 0 come from? Is that what you're saying?
Yeah.
When is cosine 1? At what angle?
Oh, okay.
There you go. Cool. I like it. And of course, I mean, so we can argue I don't have to write that, but I just wrote that as my base answer. And of course, 0 plus pi k is pi k times 2 is 2 pi k. Yes, sir.
You'll always give it as 0. You don't have to, because people say 0 or 2 pi. So, because at 2 pi it's also at 1.
Oh, yeah, so that's captured by this.
Okay, so,
So,
make
yeah.
sure you do 0.
Yeah.
Okay.
You could do 0. If you put a 2 pi
I
there
did
plus
do
pi,
0.
it's still the same because the k is going to make you go backwards and capture 0 again, or go forwards and capture all the elements. All right, maybe. Yes, ma'am. Oh, real quick. This is part A on that problem. And then part B, in this case, is going to be easy. What are the answers from 0 to 2 pi?
Just 2 pi.
2 pi.
Well, not inclusive none.
0.
Yeah, 0. 2 pi is not in there. All right. So I'm sorry. Who was asking something? Yes. Oh, okay. So there were homework problems, at least 2, that were exactly like that. I just want to say that to quell that. And for example, let me see if I remember where they were. Oh, they have to be back here. I think it's number, 3 through 10 in 7-3 are exactly like that one. So let me make one that's like what I gave you guys. Well, there's no way I can be totally fair here, so it's too bad.
It will die before I
So draw it
So
out.
it's the fly that killed the beast.
Draw it out.
What's that?
Draw it out.
Draw it out, yeah, exactly. So on this problem, I can, and this specific one is not quite like the one on the quiz. I'll say I'm in quadrant 1. Actually, this one wouldn't matter either, to be honest. In fact, we'll talk about that bonus question on this problem.
I almost got it.
So on this guy here, what can I do with this triangle?
Sine, or why is this 7?
So make a theta somewhere.
Yeah, so a really good place to do it would be there. I like it.
Okay, then-
And that, of course, is the angle I'm talking about. So if I see tangent inverse of 7/4, that wants to create the same triangle I'm creating because that's exactly what this is, isn't it? Take the inverse tangent. Right, so there's problems on the quiz number 4. Exactly what I'm talking about right now. Right. So here, what would I label what?
Y, 7.
Yeah, this is 7. This is 4. And of course, now sine 2 theta, I'm asking for sine 2 theta, and there is no way in hell. There's no way in hell that I can get that directly from knowing anything about theta, right? Sine 2 theta is not twice what sine is. This is not sine times 2 somehow. This is sine of double the angle. But what is sine 2 theta? We just saw this earlier. What's another way to write sine 2 theta? And why does it make sense? I want to write it like this. Why is this not worth anything to me? Because the only thing I know anything about is the angle theta. I don't know shit about twice theta. So if I could rewrite the question in terms of the angle I know something about, I do. That's one immediate use of those identities, is to rewrite a question or something you're interested in terms of something you actually know. Bless you. And now, how the hell do I find sine and cosine? Well, what do I need on that triangle?
Hypotenuse?
Hypotenuse.
Oh.
49 plus 16.
49 plus 16. I went trick-or-treating this morning. It's bothering me.
65.
Yeah, so 49 plus 16. 65, cool.
So 2 sine
So what's sine theta going to be?
7 or 765 over 65.
Yeah, and in fact, let's just do that. Now watch, here's where you can be a little smart about this. Because what's cosine theta going to have on the bottom?
Yep. So 4.
What's cosine theta going to have on the
Square root
bottom?
of 65.
Another square root of 65, right? So they're going to fill each other in. So there's no need to rationalize in the middle. Just got to pay attention to what's going to happen next. It tells you what to worry about with what you're looking at right then. So yeah, cosine's going to be
4.
4. So I get 2 times 7 times 4.
A big number. I don't want to do it. 56.
Over.
65.
Yeah. How can you check that?
You can't.
You totally can. Totally. Right? How do you get the angle? Yeah, so I'm not going to let you do this to do the problem. But to check this answer, you can put this in the calculator, get a decimal. Now get the angle. What's the angle here?
.25 degrees. 26 actually.
So does that check out? 60.25?
Yeah.
Yeah, okay.
It was 26 if you round up.
Yeah.
Yep. Okay, 2.6.
It's too quick.
And then you take, then what do you do with that? What's the question?
Find the sign.
Sine 2 theta. So I take sine of twice this, put that in the old calculator, and see if it cranks out the same thing that is as a decimal, right? You can check your answer here.
It does.
Like that. Oh. Thank you, my quick check. It does.
Yep. That's off by a few decimals later, but yeah.
So is that cool? For those of you that had cosine 2 theta, you can either be angry or happy, but you had 3 ways you could do this.
Yeah.
And I would rather probably not do the cosine squared minus sine squared way, because that requires me to know 2 trig functions. I'd probably rather do 2 cosine squared minus 1. So then I just have to know what cosine is. But it would work still. If you did cosine squared minus sine squared, it still works. No problem. Yeah.
Number 4 on the quiz. What was the bonus to that one?
Oh, yeah. So two ways to look at it. One person got this completely right. So in this problem, which quadrants could tangent be in?
One.
And since tangent is positive, what's true about sine and cosine?
They're either both positive.
Good.
or
They're
negative.
either both positive or both negative. Way too many people said, well, it's 7 and 4, so they're both positive. No, you don't. They reduce to this, so they could either both be positive or both be negative. So look at what we're dealing with. If they're both positive, this comes out.
Positive.
If they're both negative, this comes out.
Positive.
That's why I don't care what quadrant I'm in. Right? That's the most immediate answer. That's the one that somebody put down. That's one of the answers I was looking for. Kick ass. The other possible way to answer that is if theta, where must theta be? Remind me, where are we at? Which quadrant?
First quadrant.
So either from 0 to pi over 2
or
or
pi.
pi to 3 pi over 2. Right? So I'm either from 0 to pi over 2 or pi to 3 pi over 2. How we doing?
Yeah.
That's what theta is doing. So then what must 2 theta be doing?
Double that.
0 to pi over 2.
Pi over 2 to pi.
0 to pi over 4.
0 to
What's
pi.
happening?
0 to pi.
0 to pi.
So if theta was 0, twice theta is 0. If theta was pi over 2, twice theta is pi. And if I'm here, from pi to 3 pi over 2, where could 2 theta be?
2 pi.
2 pi
to 3 pi.
to 3 pi, right? And where's 2 pi to 3 pi?
In the
Where's 2 pi up here? Where's
Same
2
as
pi?
0.
Same as 0. And where's 3 pi?
Why?
Wow.
So 0 to pi is the same as 2 pi to 3 pi. So no matter where theta starts, it actually 2 theta ends up in the same region.
Sort of.
So that's another way to answer why am I not caring about the quadrant, because it ends up in the same place no matter what. Now, how important is it that you understand what I just said here?
Not.
Very. But the more you understand this, it means the more you can kind of piece things together, which is a good thing in general. But is this required for you to pass this course? No. But what's up, Chris?
Nothing ironic about it.
Okay. But it's nothing more than just, how do I get 2 theta? I probably double theta.
Yeah.
So theta could be from 0 to pi, 2 theta could be from 0 to pi. And 2 pi to 3 pi is the same thing as 0 to pi. They're coterminal angles. They define the upper part. They both do. That's the other way to answer that. This is the way that I thought I might get the one that I did get, because that's just a little more immediately obvious. So that's cool. This is a little bit freaky, but it's still true. And that's statistics. Let's not go there. Okay. Yeah.
So you said that once you plug in to 2 sine theta, cosine theta, it doesn't matter if they were negative or positive, they just
Because they both have to be the same sign, so this product is going to come out positive. No matter which quadrant this really wanted to be in, this is going to come out positive. Because the options for this make this positive no matter what.
So
Good.
what answer, or how were you trying to go for on that answer?
Alright, so this is the answer. This is me telling you how to check your answer if you want to. Again, you need to know how to check your answer? No, I don't care if you can't check your answer. I'll check your answer. But it's really good in the middle of the test to be able to see if you're on the right track. Right, so you figure out what the angle is by doing the inverse. You can figure out what the angle is. We know how to solve for angles.
Right.
And then you just directly plug it into what I'm asking you and see if it equals this. Cool. I lock it.
Okay, so
Yes.
For the check part, if you give us something that has negative, you put negative in the check as well, right?
Okay. Sure.
so
I'm sure. So yeah, if this inverse thing comes out to something negative, a negative
No,
angle.
like it was given that it was negative. You plug it in the check.
If my question was like negative sine 2 theta or something.
No, tangent theta equal.
No. All you care about is what theta is.
Okay.
Whatever the hell I get to here, you get what theta is, and then you plug it in.
Okay.
Yep. Yep.
So, number 4 on the quiz.
Oh yeah, you were just trying to ask me that. All right. So you guys remind me here. What is Chris? What's up?
I'm still trying trying to use that example based off of the exact same one on my test, which were just different numbers, but it's not coming up right.
Did they ask you for sine 2 theta or?
Yes, it was asking for sine 2 theta.
Okay.
So I did exactly what we did with my numbers.
Oh, they check it.
Yeah, but the checking's not coming up right.
All right. So you might be just making an input mistake somewhere here. Ask me here in a bit. Because that's, again, not something we all need to be able to do. Number 4, remind me this. What's sine of A minus B? Yeah, sine A cosine B minus cosine B. And of course, if I had cosine of A plus B, for example, cosine
minus sine A sin B.
yeah, no. Remember, no. Remember, cosine's a jackass. Me, and then change your sign to an F. Right? Minus sine A, sine B. Cool. So if I ask you to do cosine of angle minus some other angle, then you can use, something related. So that was a minus, this would be a plus. You can just use one of these formulas to break out what this really is. So number 4, on one test I asked something related to cosine of cosecant inverse of 2 minus,
Tangent.
what you want to say? Sure, tangent inverse of 7.
Those two were switched.
I don't want to do anybody's work for them.
Doesn't really matter.
So when you first stare at this, you might go, what the hell am I supposed to do with this? And some of you guys did something like distribute, which is neat. This is not a function. This whole thing is a function. This is not something times something. This is something of something.
So do we need to make little triangles with these?
Yes. Yes, ma'am.
So on this, if one of the cosines is an angle we know and one of them isn't, how do we write the final exact answer?
I don't think I gave any, I didn't give anybody an angle, like values that you know, not an angle that you know.
Yeah.
Well, then it's a little bit easier. It should be a little bit easier, because then you can make your triangle easier. So I think one of them was,
the final, once you draw the triangle, you get cosine something, cosine something, plus sine something, sine something. If it's like, one of them's like, cosine of 1 over root 10, cosine of root 3 over 2. So if we know one of those, but we don't know the other.
so wait. So if you mean like cosine inverse of root 3 over 2, something like that?
And the other one was 1 over root 10.
I'm not sure. You made it. It's not easy, Dennis. Okay. Okay, so a couple things.
Did I do something wrong?
Couple things. You ready?
Yeah.
Go sit down. So this is exactly what you're talking about right here. Yeah, so somebody help me out. The triangle for this guy would look like what? Where's the 2 go?
2 radius.
Good.
And the sine is 1.
Good, the sine piece is 1. I like it. So of course this is going to be root 4 minus 1. 3. Alright, so that's, if some of you guys might notice, that is based on fundamental values that we actually know. So it doesn't change anything. It doesn't change anything. Nothing's changed. If it was something you didn't know, you'd do exactly the same thing. The mistake you're making is, I wouldn't then say, alright, so how would I break this thing down? Cosine of the difference.
It's cosine, cosecant 2.
Good. Cosecant 2.
Cosine tangent 7.
Tangent inverse
Plus.
7. Plus, good.
Sine cosecant 2.
Sine, cosecant.
Tangent, or sine tangent 7.
Sine, tangent inverse 7. So we applied this idea here, right? Because these are just angles, so I can totally do that anytime I want to. Like this kind of thing. So, what is the cosine of, which one of it? Yeah.
Of that triangle.
That is the cosine of this angle here.
Right, 3 over 2.
So yeah, so what's wrong if I put this? What have I done wrong?
You're multiplying it, I don't know.
It's not the cosine of this.
No, that is.
The cosine of this is that. Cool. And then here should just be a number. So I still have to make a little triangle there, right? Same way we did that one. So in this problem, I'm going to need 2 different triangles because I have 2 different angles in there. So wherever wants this, I'm going to use this triangle. Wherever wants this, I'm going to use this triangle. Is that cool?
Mm-hmm.
All right, so get you started on corrections there. Uh-oh. Exercising the
No, I had to bless him.
math. Oh,
What?
you have been blessed. Don't worry. Your sneeze is covered. Your soul is staying in your body.
Pretty cool.
Okay. But there are ones in the homework that were just like that. That's why I felt completely justified to do those. All right, so anything else from the quiz or the practice test or homework?
Let's just.
It's wide open. Or you want to do examples of kind of problems?
I'm kind of confused. How do you know again when there's 2 triangles when you're using wrong signs?
Oh, I love it. Beautiful question. Because everybody on number 1, I think one person, maybe 2, I can't remember, got the second triangle. I think a few people understood that there was a second triangle that existed.
I didn't.
Let me see. I don't know if I trust myself to create one that actually works because it's a little weird. So let me see. Let me base this off of something on the quiz. All right, let's try this out real quick. So it's a good idea to draw the triangle just to be a little something, and it doesn't matter if it's to scale or anything. So C is 12, B is 10, and I know angle B is 47. So that's very obviously to scale. It's awesome. But again, it's just, who cares? It's rotated away from your toy, whatever. It's just a quick reference. So what can I set up? What law do I want to use here? Yeah, why do I want to use law of sines?
Because you can.
I love it, because I can. Normally, if I can use law of sines, that means normally that I'm in a situation where I cannot use law of cosines. Not always. But here I can definitely set up that ratio between the b's. So what would that look like?
Sin B and B.
Minus 47.
47. And which angle can I get?
C.
C, because I know his side. Sine C. 12. I love it. So if I solve for sine C, I get 12 sine 47 over 10. Now, I had just a couple people that would figure out what this was and then think that was the angle. That's not the angle, that is the sine of the angle. So how do I get the actual angle? Inverse sine. I love it. So go ahead and do that. What's the inverse sine of this mess here?
61.36.
61.36.
36.
Does everybody agree with that? Crowdsourcing. All right. So what do you have to check right now? That's possibly C1. What might C2 be?
What's 180 minus 61?
180 minus this. Right? So 118.64. Just do 180 minus this.
And then you got to subtract your other angle of 47.
Yeah, if the 47 and this leave room for another angle, then that exists. And what's 47 plus 118? It's less than 180.
165.
That's what you check. Does that make sense?
Uh-huh.
And the real quick way, don't say when I have, you don't have to realize that it's when you have SSA or AS the other way. Whenever you take an inverse sine, you should take a second. Because inverse sine is the one whose range doesn't really quite match up with what we need. So I just got to take a second and check the other possibility. In fact, if you use law of cosines once, and then you start using law of sines after, you could still run into trouble. Now, there can't be 2 triangles when you're using law of cosines, but the sines might give you a reference angle. So just anytime you use law of sines and you get an inverse sine to get somewhere, you have to check to see, is that a reference angle for something? In this case, there might be two triangles that exist. So I have to do both. So I have to figure out what A1 is, and I have to figure out what angle A1 is. And over here, A2 and angle A2. And please, dear God, put degrees on the degrees. And maybe circle your answers. Because a lot of this is a lot of work. And I'm like, okay, where's your answer? Okay. So put a little box around the answer. Yes?
Is this going to be required from us on the test?
So you're going to have to solve triangles. And could this happen when you're solving triangles?
Yes.
Yes, because it just did. So what do you think I'm going to do? Do you think there's going to be a problem on the test like that?
Yes.
Probably.
Could be. Or I might not. And you still have to check it. If you do this and you don't check, or you don't show me the work of the check, if this would have come out to be 138, would another triangle exist?
No.
Because 138 plus 47 doesn't leave any room for another angle, but you got to show me that. Right? So you can argue, no, you got to tell me why. I'm not saying you sound like that. Sometimes you got to show me why you didn't have to worry about this. Yes, sir.
You say you got the problem 8 on the practice?
Yes, good. Thank you.
Are you going to finish the rest of the
Sure, that's a good idea. Let me give you the answer key and then we'll finish out the practice test.
And then thank you.
Sure.
I'm not looking at that. I'm looking over there, if you notice.
No.
All right. So I stopped short of number 9 and the following. So, oh yeah, we could have just done that. Didn't think about it. 9 is a good example of what we just did. So let's see on number 9, I can draw a triangle. Let's see if I can make it a little bit. Here's 42 degrees, here's A. B is 6. No, 6. And A is 8.1. So which law do I want to use? That's right. So, which ratio can I completely make?
A and B.
Yeah, so the A1 sine 42 divided by
8.1.
8.1 sine of B over 6. Let's see what we get here. This thing is in degrees. There it is. So what do you guys get for angle B?
29.71.
Yeah, 29.71?
Yep.
Yep, cool. So it could be B1. What would B2 be if it exists?
150 150.29.
Yeah, 150.29. And considering that the other angle I have is 42, is that possible?
No.
Because that leaves nothing, that leaves negative for the last angle.
Yep.
And the last angle says, shit, I get it. So then you throw that guy out. Alright, so since 42, 192.29 greater than 180, no. So you got to give me a little bit of reasoning as to why the second triangle doesn't exist. So then what can I figure out
Angle
next?
C.
Yeah, I can get
Angle C.
angle C, good. So here I get 29.71. So angle C has to be,
108.29.
yeah, these two added, subtracted from 180 is 108.29.
Yep.
And of course, then I can finally get
Sec 2 or C.
side C. I love it. So make sure at the end you got 3 angles total that you figured out, or I gave you, and 3 sides total. I think there were a couple people that left off a side. Just completely solve the triangle. So how do I get side C?
Sine 108.29 over C is equal to sine 42 over 8.1.
I like it. Always go back to that one you know for sure. And then just solve for C. Now, why do I not have to worry about anything weird happening here?
Because it was given to you. Sine
Because we
42.
know that there's no other triangle.
Because I'm not going to do an inverse sine, right? I get solve directly for C. Wasn't really a trick question, but. So we see how to do this. When you definitely know you can use law of sines when you can make a complete ratio. And when there's another one that's just missing one thing. If you can't make a complete ratio, or you don't have something else that you can make half of, then you know you got to use law of cosines. Those two together cover all possibilities. So what do you guys get for? Now I'm all this stuff.
11.49.
11.49
49.
centimeters. Box off. Your answer is 11. So that's number 9A. What about 9B? I bet you $1 million you use a lot of cosines here. Let's see. So I get 6.3, that's A. A. Here's B. Here's C. 105 degrees. And there's a little B that was right. See? Bob Ross and Gina. So, I mean, when I know one angle, and I got the 2 sides surrounding it, that's just screaming law of cosines. It's the traditional basic. Now, of course, law of cosines can also handle if you just know all the sides. Cool, because law of sines would go, holy shit, I need an angle. Right? Law of cosines doesn't. So, what can I get immediately off of this?
C squared.
Yeah, can you figure out what side C is? So it's C squared equals
A squared plus B squared minus 2AB.
minus, yeah, so if you guys had a plus there, so minus
2AB.
2AB
Cosine 105.
cosine C. So see how these match up? Right? And everything in the middle is all about the other two. Okay. Cool. And then so now just throw in what you know. C squared equals 6.3 squared plus 9 squared minus 2 times 6.3 times 9. And one thing that really troubles me is the number of people that did this and then multiply. Order operations. I can't do subtraction before I do the multiplication, right? So this is a coefficient of this. So you can't just put all these numbers together and just leave that coordinate out. You have to figure out what the hell this thing is before you can subtract it. So if you just put the calculator just like that, you're fine. Out there, eat that thing up. Yeah, so you get C squared is like 150, blah, blah, blah. So C is
About
square root
12.25.
of that. I like it. 12.25 kilometers.
Yeah.
Coolness. And then I could use either law of cosines or law of sines to get the other stuff. Right? And then, let me see if anybody understands this. If you do want to use law of sines on a problem where you started off with law of cosines, use a law of sines to get the biggest angle. That will make it so that no reference stuff. Use a what am I trying to say? So always get this one first with law of cosines if you have to get an angle. Get the biggest one through law of cosines, and then the other two you get through law of sines. Because this would be like a reference angle for inverse sine. Could inverse sine give you 105 degrees? What's the range of inverse sine?
0.
Negative 90 to 90. So it could never give you a 105 degree answer, right? All right, but that's just a little, aside
So
note.
you
Yes.
say you could just go law of cosines.
Yeah, totally. You
Okay.
could finish this problem out with law of cosines. So how would you get angle B? What would you put on the side if you want to use law of cosines? C squared equals A squared plus C squared minus 2AC cosine
Of B.
B. So B's on the outside and AC's on the inside.
So B.
So 9 squared equals 6.3 squared plus 12.25 squared minus twice 6.3, 12.25. Cosine B. And the beautiful thing about inverse cosine is it's got no problems. All of its angles are between 0 and 180, which are beautiful for triangles. We're like, yes. Just be careful with order operations when you're solving this thing.
6.3 squared plus 2.5 squared minus 9 squared
45.2.
over 2 times 6.3 and that's cosine.
Got it. So I get cosine B equals something like 0.704, blah, 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 blah.
Mm-hmm.
And then you do inverse cosine, I like it.
45.2.
Don't put the rounded thing in there, just do inverse cosine to that thing. Yeah, and you get 45.2, I like it.
And then A is 29.8.
Yeah, and then A, you got A, 45.2. And then A is going to be
29.8.
29.8. Sorry. Just because that'll make 180, right? That's awesome when you get two angles. So definitely doing the law of cosines 3 times. It's crazy. That last angle you can capture easily. So that's 9B. The last 3 are from the book. Let's see. Number 10 refers us to page 486, number 80. It's the one with the boat. Yeah. So you got a little boat, wow. And you got a shoreline, wow. And you got this siding there, this siding there. Here's 68.9, 42.3. Call this A, they call this B. Yeah, they call this C. And they're asking us something a little bit weird. Points A and B are 120 miles apart, so thank God we know one more thing. So this is 120 miles here. And they ask us what's the shortest distance from the boat to the shoreline. So of course, the shortest distance between a point and a line, because you can look at a boat like a point. Is that cool? Shortest distance between a point and a line is going to be straight in what way? It's going to hit that other line at a
90-degree angle.
90-degree angle. Love it. Cool. Does that make sense? Anything else is going to be a little bit bigger than that line would have to be. So it would be straight across. And the minute I draw straight across, you get a little excited. Because now we have a couple of right triangles, right? So in order to find this distance, we'll call it, remarkably enough, D. what do I have to know about one of my two right triangles? Yeah, I've got to know any of the lengths, right? Especially with D, I'll be honest, but I've got to know the hypotenuse here, or this little piece there. So I need, if I want to use this little skinny triangle to figure out what D is, that would kick so much ass, because it's a right triangle. I could just use trigonometry directly, not any laws of craft, just exactly what the trig is. Because it's a right triangle, is that cool? So now, if I need this side, I can kind of look at it as the big triangle again. So how am I going to get this side? Do I have what I need to get this side?
No.
Yes.
I do, sort of. What's this angle?
42.3.
Oh.
Plus 68.9 minus 1.
Yeah, 180 minus these two. 2 is going to be 68.6.
68.8.
Alright. So then what can I use to figure out? So we want to know this side. We'll call this side. Well, we should call it what? We should call it side A. Alright, sorry, set up for us. So then what do I set up to figure out this?
Sine.
Sine 68.8 over 120 equals sine 42.3 over its side, which I want to know. So that's why this is towards the end of the book. It's a two-step process. You have to get this to be able to get this. Right? And that's normally what they consider a little bit harder problem, one that requires a couple steps. So, now again, you don't have to worry about anything weird. You're not taking inverse sine, solving for A. 86.62. Miles? So now let me focus on my little skinny triangle, right? I only need the big ass triangle to get that side. So let me focus on my little tiny sliver here. Look at this right angle. I've got this side is here. And I've got 68.9 degrees here. And I'm trying to figure out this. So what trig function relates?
Sine.
Where are you? No?
Sine.
Sine, yes. Sorry. So sine of 68.9. No, don't go there. I don't have to do any lost signs anymore, right? What is this? I could.
It's just
But sine of 90 is 1. So, I mean, yeah, sine of 68.9. What's the definition of sine of 68.9? It's going to be the y side over the hypotenuse. Right? Just because we learn law of sines does not mean suddenly everything else is gone. It's just I could use law of sines when I don't have a right triangle. If I do have a right triangle, why? Why would you do that? It'll work. But why? And so whatever that times that
Because
is.
you've forgotten the easy stuff.
Yeah, exactly. So whatever you get there, what do you get there?
80.81 miles.
80.81? Yeah, good. Sounds familiar. So that's number 10. Number 11's got 2 from the book. So they go to chapter 7, review, number 71. Oh yeah. This one sounds weird, but it's not that bad. We got this little triangle here. Alright, so you're driving along, and if you're further back, this angle would be, if you think about it, the angle would be really small. So at some point, the angle gets large enough that you can actually make out what this thing says. Otherwise, it's too far back and all the letter is smooshed. You can't see it well. Right? Of course, some of us didn't eat enough carrots, so we might as well get a little bit closer. But for the person driving this car, they need a viewing angle of 2 degrees or greater. So the minute that becomes 2 degrees, they could kind of make it out. So what's really funny to me is you could do part B really quickly right now, but part A says, express the viewing angle theta as a function of the distance x between the driver and the sign. That sounds horrible.
Cosine.
But what can you immediately set up? What kind of triangle is this?
Tangent.
Yeah, it's a right triangle. I love it. Do they say what they need to say? Do they have a little symbol there? They suck. It's too bad for us.
Tangent theta.
But it totally is like
Tangent.
And so yeah, so tangent theta would be what?
X or 10 over x.
10 over x. I love it. So then what's theta? Don't overthink it. Don't tell me 7.
Inverse.
Solve it. Yeah, good, exactly.
Inverse tangent.
So part A is asking for theta as a function of x. There you go. And then part B says, that's where they say 2 degrees. At what distance does the sign first become legible? So now I can use this and do what? What do you want to make equal to what for part B?
A equals 2.
Theta equals 2. Look, so this would be 2 degrees. And this is what I meant by part A kind of takes you backwards, because you really want to take the tangent of the damn thing, right? You could just plug 2 in here, it'd be a little bit more sensible. This way it's a little bit nonsensical. You guys with me? Just plug and chug here, right? This isn't nearly as bad as when you first look at it, you're like, this could be bad. But it's not at all. Simple tangent.
So then what do? Just multiply by the tangent?
No. Don't ever say that. I don't multiply anybody, just take the tangent of both sides. It's good. And it is important the way you say it, because it gets in your brain the wrong way, and you're doing weird stuff later.
Well, I know what I mean.
But understand, if you say it wrong, your brain's going to start listening to you. It's no good. And so here that goes away. And then the tangent of 2 degrees, you do that in the calculator, solve for x. Right? So you get x equals 10 over that. Too many people solve this kind of thing completely wrong. They don't get it. You multiply the x up, you divide the tan 2 down.
316.
Right. What do you get, sir?
286.36.
Sounds about right. Light years?
Well, it doesn't exactly give a feet. Doesn't give it.
Yeah.
It does.
Okay.
Yeah, because 10 is in
Yeah, feet.
feet. Good. So if you're that far away, that means it's starting to be legible. If you're this dude, anyway. Some of us might require a larger angle, viewing angle. 72 looks like it's going to be kind of rough. 72 kind of sums up what was going through my mind earlier when we had a fly flying around. King Kong sitting up there. Let's see. So this is the 72 I like. 71 is trying to get this in there, and it's just kind of forcing this in there. I didn't need this for that part. It's just like forcing me to write theta by itself. 72, you got to. So you got a 380 foot tall building. Here's my very skinny building. And then you have a 40 foot tall tower. I don't know what the person who was making this problem was doing, but what does this add up to be?
420.
All right, so 420. Blah, 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 blah. So then you've got this little, whatever the hell it is over here. It's not a boat, it's on, whatever there. It's a little person. And he's looking up here, he sees the top of the tower, and he sees the base of the tower. It's not too bad for me, it's almost straight. Jeff, just let it be. That's so much better, Jeff. So I'm looking for this angle here. Now, does anybody immediately see anything that would help us? Shit. Yeah, if I just draw this in, I've made 2 right triangles, right? Beautiful. I thought that's what you were going to say, that's why I was saying.
Yeah.
So then I can get this angle, what do you want to call that angle? The big ass angle. Let's call it big A, big ass angle. and then this one's B for big S angle, and this we'll call this one T for tiny little angle, or whatever the hell you want to call them, alpha and gamma if you like Greek letters. So theta in general, how do these three relate?
A equals T plus theta.
Yeah, A is T plus theta, so theta is A minus T, right? So if I can figure out what that angle is, and I can figure out what that angle is, theta would just be the difference between the two. Is that decent?
Sure.
We've done problems sort of like this where we look for the little leftover angle piece and to answer the question. This is a little more direct. So, do we know anything else here? This is called as X. Blah, 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 blah. All right, so we don't know much of anything.
They want to know what just
Express the viewing angle theta as a function of the distance x. So we're not supposed to know much. We don't know how far away they are. We don't know what the theta is going to be. But so for this, let's talk about the tiny one, the T dude. What can I set up? What relates what I know and what I don't know? Tangent. So tangent T equals
380 over
good 380 over x. So what's angle T?
inverse tangent 380 over x.
And of course, why am I trying to get angle T? Because I know that's what I need. If I can get angle T and I can get angle A, I can write what theta is. So of course, how am I going to get angle A?
Same way.
Same damn way, just the big ass triangle. Right. So tangent of A is going to be
420 over x.
good 420 over x. So A is
Inverse tangent.
inverse tangent of that. So what's theta?
A minus t.
Yeah, theta is A minus T. So theta is this dude minus this dude. Got it.
So can you just like pull an inverse tangent out of both of those?
No, again, this is not multiplication, so you can't factor it out. But that's why do you not care? Because part A says get theta as a function of x. We did it. We're done with part A. What about part B?
What distance from the building is the viewing angle theta?
Good. And they got a little picture of your graphing calculator. So you just plug this in the graphing calculator, and it should look like that, roughly. And right in the middle should be 400. Did this earlier. I think it's 400. And that would be the distance you have to be, so the viewing angle is the biggest possible. Right? In case you needed to know that. Which you did, because I told you to do that. Alright, so that's the rest of the answer key. Anything else that we want to go over, specifically, in general, or any way in between? Okay. I'll probably be in my office about 8:30 on Monday, so if you want to come by a little earlier for anything, I'll be there. Otherwise, try to enjoy your Halloween. Forget about math for a while, do whatever the hell you're going to do. Or dress up as a... and figure out how to make that happen. Yes. Dress up as an inverse trig function.